In the summer of 1995, Dean Pomerleau and Todd Yoakum, of Carnegie Mellon University's Robotics Institute, took a 2,850 miles journey across America in a minivan, which drove autonomously for 98.2% of the trip. Since then, the entire autonomous mobility sector has been at work to cover the remaining 2%. The main challenge is guaranteeing safety in traffic situations where one or more unusual operating circumstances may take place. And those prove to be hard and expensive to identify, test, and optimize. That's where 5G-Blueprint comes in, a EU-funded project focusing on an alternative approach to solve this problem: teleoperation. When teleoperating, part or all tasks in the act of driving a vehicle or sailing a vessel are performed by a remote operator, usually over wireless communications. 5G-Blueprint focuses specifically on direct control teleoperation, where humans perform the actual dynamic driving task. While direct control teleoperation, not being a form of driving automation, has been overlooked, so far, in the quest to bring autonomous vehicles to roads and waterways, we see it as the missing piece of the puzzle for real-life deployment, with direct control teleoperation and automation complementing each other. Direct control teleoperation can allow splitting up L4 vehicle trajectories in different segments, with different operational design domains, and assign each of them to either automated driving or remote driving, depending on how difficult they are to automate. The idea is to do exactly what Pomerleau and Yoakum did in '95. Rely on human drivers to navigate that challenging 2% of the route. But thanks to 5G, those drivers won't need to be physically present in the vehicle anymore, and could remotely jump in and out of different vehicles to take over whenever needed, which also reduces personnel cost. Before the advent of 5G, the network capabilities necessary to pull all this off were just a dream. But even now, the seemingly needed combination of mobile broadband and ultra-reliable low-latency communication, let alone the need for seamlessly cross-border connectivity for international transport, might be too challenging to realize. This means that it needs to be validated in depth if and how 5G can provide the connectivity needed for direct control teleoperation, not only from a technology but also from a business and governance perspective. This is the main purpose of 5G Blueprint.